All right, guys, here is our 4.3 part 2. I got to the end of J period, got through lesson with both J and A, and then quickly realized that I forgot to hit record. So here we go. First thing I want to go over, since a lot of us don't remember our special right triangles, just a quick little introduction, little reminder about our 45, 45, 90 triangles and our 30, 60, 90 triangles. Now, these are all based off of the unit circle, which we'll talk about a little more in the upcoming lessons and how those angles and the lengths and stuff were derived. But guys, it is a pattern, and we've got to know and understand the pattern and how to find things. Because when you're given one of these triangles and it says to find, a certain length or something like that, and you have to give an exact value, that means your answer has to be in a radical form. You're not gonna be able to just use your calculator. So looking at our 45, 45, 90s, right, we obviously have our 90-degree angle, which is our red square, and then the other two angles are both 45 degrees in measure, which is right here. The legs of the triangle, both the legs of the triangle are the same length. The hypotenuse is the length x, whatever the legs are, times the square root of 2. A lot of times it's written like this because it's the square root of 2 is behind it. When you find the hypotenuse, if you have the leg, you times the hypotenuse by the square root of 2. If you have the hypotenuse to try and find the legs, you divide by the square root of 2. Now, the 30, 60, 90 is a little more detailed, but not really that much different. You just have to remember that always across from the across from the 30 is always your shortest leg. And you guys should remember that from basic geometry, that shortest side is across from the shortest angle and vice versa. The biggest side is across from the biggest angle. So in a 30, 60, 90, the x value, the shortest leg, is always right across from the 30 degree. To find the hypotenuse, you just multiply that shortest leg by 2. And then to find the longer leg, the side that's across from the 60, you're going to multiply whatever the leg length is by the square root of 3. So if you have these problems here, you'll notice that this is a leg, and this is a leg, and this is your hypotenuse. In our 45, 45, 90, if you look at it, the legs are equal length, and then the hypotenuse is whatever the leg length is times the square root of 2. So your value of your hypotenuse is 3 square roots of 2. If you put that in your calculator, you will get some sort of a decimal answer, which is great, but when we are talking about exact values, you have to have a square root in your answer. When we talk about this 45, 45, 90, it looks similar, but notice here, these legs are what we're looking for. So I know that this hypotenuse is the value of the leg times the square root of 2. So I'm going to set this equal to the value of the leg times the square root of 2. And then I'm going to solve for x. So I divide both sides by the square root of 2. So I get x equals 5 square root of 2, which we can't leave. At WebAssign, that's okay, but for Mrs. Meadows, it's not. So we're going to rationalize. And we get that x is 5 root 2 over 2. And that would be your leg length. Now, when we talk about a 30, 60, 90, right, we're finding the values of s and t. So in this case, we're finding the shortest leg, which is our x value, and we're, finding the side of our t, which is the hypotenuse. That's 2 times that. I know that across from the 60 degree, that value is your x times the square root of 3. So you simply just set that side equal to x root 3. We're going to divide both sides by the square root of 3. And then we're going to rationalize because that's not okay to leave it like that. So we're left with my x value here is going to be 5 root 3 over 3. That's my s. My s value is 5 square root of 3 over 3. If I want to find my t value, well, it's going to be 2 times the shortest side. So it's 2 times 5 square root of 3 over 3, which 2 times 5 would be 10 root 3 over 3, and that's going to be my t value. So those 30, 60, 90s, guys, you've got to get that pattern down. We've got to remember it. If you don't, go ahead and look it up on YouTube, Khan Academy, whatever, to familiarize yourself with that. This next slide shows our six trig functions, the sine, cosine, and tangent of our special angles are 30, 60, 90s, and our 45, 45, 90s, all around the unit circle. So if you guys notice, the sine of 60 is the same as pi over 6 is 1/2. That's the y value of the ordered pair. Your cosine of 30, cosine pi over 2, is root 3 over 2, which is the x value of the ordered pair at 30 degrees. Your tangent of 30, which is pi over 6, is root 3 over 3, which is the same as your y value over your x value. So we've already talked about how to find these. You guys can note these on the unit circle. But on your web assign, they'll say to you, like, what is the tangent of 30? Then they want the degree measure. They give you 30. They want the radian measure. That's pi over 6. And they want the function value. That would be this, the root 3 over 3. These are super, super, super important for you guys to understand and be able to recognize. If you notice here, 30 and 60, those are complementary angles of each other. If you notice, the sine of 30 is 1/2, the cosine of 60 is 1/2. If you notice, the cosine of 30 is root 3 over 2. Well, the complement, the sine of 60 is root 3 over 2. Everything on the unit circle is closely related and all derived from that unit circle. Talking about real world life word problems and applications, you guys we're gonna practice this a lot on Monday, but you will have word problems on your 4-3 quiz. You'll have it on your 4-1 to 4-4 test and all sorts of stuff like that. When we talk about angles of elevation and angles of depression, angle of elevation means you're on the ground, the observer, whoever it is you're talking about, and your line of sight is going up. So the angle formed between that horizontal line, your quote-unquote x-axis, maybe the ground or something like that, and the angle at which you're looking up at, this is your theta. This is the angle of elevation. The angle of depression is a little bit different. You can look at it the same way, but you have to think about this. If I make my right triangle here, and I have an angle of depression, my angle of depression is from my line of sight, my horizontal, to the quote-unquote top of my triangle. So if they tell me here that the angle of depression is 35 degrees, that's not my theta. You could put 35 down here because two parallel lines cut by a transversal, the opposite alternate interior angles are congruent. Or if you're going to try and figure out what this piece is up here, if you want to use this as your theta, you would have to take the 90 degrees that this right triangle makes and subtract the theta that they gave you. In this case, I gave you 35 degrees. So the remaining piece of the degree measurement would be your angle here. And we'll talk about that a lot on Monday in class, but I just want to talk to you. I want to give you guys I'm going to give you two examples right now of angle of elevation so we can talk about what the word problem is actually asking. All right, so again, guys, remember, we're talking about solving right triangles. So as soon as you see the word problem, the first thing I suggest everybody does is draw a right triangle. It doesn't matter how you draw it, if you want to draw it with the right angle on the left, bottom left, right angle on the top right, whatever, however you want to. You need to understand the makeup of a right triangle. This would be your x-axis value, your horizontal. I'm going to talk about it as the horizontal versus the vertical. This is your horizontal. It's similar to your x-axis, but horizontal, we usually talk about how far something is away from something else, meaning from where you're standing to the base of a building. You're on a boat, how far are you away from the dock? Those sorts of things. When we talk about the vertical, this is always the height. How tall is a building? How tall is a tree? How high is the blimp above the stadium? Those sorts of things. Vertical. I spelled vertical wrong. Okay. Then our hypotenuse, all right? Our hypotenuse is usually something leaning against. We'll talk about a ladder leaning against a building or a house. We'll talk about a ramp up to a fourth floor. You'll talk about a guy wire that holds up a tower, similar to those. I used the example today in class of if you're driving down the highway and they put in those beautiful big new palm trees, and then they have the 2x4s that kind of support on the outside to hold the tree up. Those would be your hypotenuse type lengths of situations that you're looking for. And again, the more we practice this, the easier it'll get. But if you're looking at this and it says a surveyor is standing 50 feet from the base of a large tree. Okay, so let's think about this. You have the bait. Here is my large tree, and my artistic skills are about as good as my 4-year-olds. So here's my large tree. A surveyor is standing over here, right? And it says that he's measuring an angle of elevation to the top of the tree. That means he's standing 50 feet from the base of the tree, and he's looking up, angle of elevation. He's on the ground looking up at an angle of 71.5 degrees. So there's my theta right there. How tall is the tree? I want to know how tall the tree is from the ground to the top. So I'm looking for the height of this tree. So in reference to the theta that they gave me, that angle of elevation, what is x? My x value is the opposite side, and my 50 would be my adjacent side. In reference to that 71, the opposite side is your x value, and the adjacent side is your 50. So what trig function uses opposite and adjacent? Well, that would be our tangent. So we've done problems in the last couple of days that was tangent of theta equals, and you put the sides over each other. Well, in this case, we're looking for a side, so we are going to use the angle that they gave us. So we just set up a very simple equation that says tangent of 71.5 equals our opposite side, we don't know what it is, over our adjacent side, which is 50. And as you guys notice, you've created a proportion. It's a fraction equal to a fraction. And how do we solve that? We cross multiply. So I'm just simply going to say x times 1 is x equals 50 times the tangent of 71.5. Now, this is very important, this step, because you guys, first of all, you have to be in degree mode. Your calculator needs to be in degree mode. If it's in radians, we need to change it. If you're not sure, ask me on Monday in class. I went over it with some of you today. But talk to me and make sure that you guys are in the correct mode. But what you would do is simply hit 50 times the tangent of 71.5. Now in class today, some people were doing this and they got some really crazy answers like 0.034. These are word problems and they're applicable to real life. So we need to understand that I'm talking about a person standing 50 feet away from a tree. And I want to know how tall the tree is. Does it make sense that the tree would be 0.023 feet tall? No. So that's, if you get something like that in your calculator, you need to rethink. You need to relook at it and say, am I in the correct mode? Did I hit the correct button? Did I use the correct trig function? That sort of thing. But in your calculator, y'all, if you hit 50 times the tangent of 71.5, you get 149.43. Now, again, you guys are always saying, do we have to do this? Do we have to do that? You need to read the directions. If the it doesn't state here, but on your test or quiz, if it says round your answer to the nearest foot, your answer here, excuse me, would be 149 feet. If you don't round correctly, if you don't read directions, you will get points taken off. So just be aware of that. Now I look at another question. It says a large apartment building in New York City. Doesn't matter what we're measuring or where we are, but you need to understand that we are talking about right triangle trig. So I'm going to draw myself a right triangle. It says an apartment building stands 130 feet tall. That's my height. 130 feet tall is my height. That's my y-axis. So my building is 135 feet tall. It says the angle of elevation measured by the base of a fire hydrant. Well, here is a fire hydrant right here. Again, amazing art skills. But there's my fire hydrant. It says right here that the angle of elevation is 37 degrees. How far is the fire hydrant from the base of the building? Here is the base of the building, and here is the fire hydrant. I want to know how far it is from here to here. So this is the value I'm looking for. Very important that you set your triangle up correctly. So again, in regards to my theta, and we'll talk more about angle of depression problems on Monday, but in regards to my theta, 135 is my opposite side, and x would be my adjacent side. So what trig function uses opposite and adjacent? That would be tangent. So we're going to say the tangent of 37 equals, my opposite side is 135 over my adjacent side, which is x. And remember, this is over 1. So again, we've just set up a very simple equation. It's a proportion. It's two fractions set equal to each other. But this is different because this time my variable is on the bottom. Again, I'm going to solve it the same exact way. I'm going to say 1 times 135 is 135 equals x times the tangent of 37. Now, guys, there's no reason to evaluate the tangent of 37 right now in your calculator. Just leave it like that because it's an irrational decimal that you don't need to start rounding at this point. What you're trying to do is solve for x. So we're going to divide both sides by the tangent of 37. We want to get x all by itself. So making sure that your calculator is in degree mode, you're going to say x equals, and you hit 135 divided by the tangent of 37. And you get 179.15 feet. Now again, if the directions said round your answer to the nearest foot, you would tell me it was 179 feet. Now again, you should be able to check your calculator. If you were in radians, it might give you a completely different number. It might give you a negative answer. Should, when you're measuring length, ever you get a negative answer? Absolutely not. So just be familiar with that. Pay attention to that. Little things like that, guys, you have to stay on top of. Now, again, we're going to talk about our 30, 60, 90 and our special right triangles and all that. We'll talk about it more in class on Monday. I'll give you guys some practice problems. And we're going to work on some word problems from the book and that sort of thing. I'll also do the WebAssign. I know you guys had some WebAssign questions on that one problem, but I really want you to try and figure it out. Try hard to problem solve and figure it out. We'll go over it on Monday. Have a great weekend.